Hello and welcome to this lecture where you are going to start learning some pre-processing techniques when working with machine learning. In this lecture, the focus will be on missing values and normalization. I'm going to drag and drop the datasets components and let's use a dataset named adults. Double-click to download it. We can visualize some information about it. Data info components. There are more than 30,000 instances and 15 columns. The target is a categorical variable with two classes. Let's visualize some of the data. Double-click. See here that the target is the first variable, which is called y. The goal is to predict the income. If it is less or equal to 50,000 or if it is greater than 50,000 based on the data about the people. For example, the age, work class. This attribute is called final weight. It is a pre-built calculation. The education number, marital status, occupation, relationship, and so on. In short, we are going to use all this data to predict the annual income. We are going to perform the classification test using KNN algorithm. So we are going to select it in the Model tab, connect the data table to the component. We can see here that select data is pointing to data. We need to do the following, data to data, to use all the data available in the dataset. If you want, you can set the number of neighbors to be used in the calculation. Let's keep the default value, which is 3. Now we can evaluate the algorithm using test and score components, connect the data to test and score. Here we need to change data to data. After the process is complete, double-click on the test and score component and see here that the classification accuracy is 76%. For this test, I'm going to use random sampling, 80% of the data to train and 20% of the data to test. We can see that the classification accuracy is 75%. I'm going to open the data table to visualize some of the instances. For example, there is one interrogation mark for the work class column. It means a missing value. We don't have information about the work class of this person. And it happens for some other instances. For example, work class, empty here, and it is empty here. And the same happens for the other attributes. For example, occupation, empty. Occupation for this other person is also empty. And we can also visualize that the native country is also empty. It may be a problem because some algorithms do not deal with missing data. So you need to apply some pre-processing before sending the data to the algorithm. We can visualize here in the info that 0.9% of the instances present missing data. What we need to do is to apply some pre-processing in order to put some values here. We can see that for instance 62, there are missing values for all these columns. we can go to the Transform tab and select Preprocess Components. We connect the data table to the preprocess. Here we need to specify data to data, double-click, and see here all the options that are available. The one we are going to use is Input Missing Values. Double-click. There are 3 ways to deal with this kind of attributes. We can calculate the average for numerical attributes or use the most frequent for categorical attributes. Replace with a random value, or you can even remove rows with missing data. It is recommended when there isn't so much missing in your dataset. Let's select this one first. Then we use another data table. We can see here the original data. And when we open this one, see that about 2,000 instances have been deleted from the dataset. And now we can visualize the message, no missing data. It's quite a lot of data to be removed from the dataset, so I'm going to replace for the average or for the most frequent. It is going to pre-process all the columns. Now we can visualize instance 62. It was empty here. It has been replaced and the new value is private, which is the most frequent. We can see here that the occupation is not empty anymore, as well as the native country is equal to the United States, which is the most common in this dataset. We can visualize the statistics. All instances are in this new dataset, and there is no missing data. Now we can try to test the classification using KNN algorithm. Change here data to data. Let's use another test and score component. Connect the data to the components. We have here 75% accuracy. And now we can see that the classification accuracy has improved because we are removing missing data. So it is a good strategy to increase the performance of the algorithm. Another preprocessing that we can apply is the normalization. We can visualize that in the original dataset, there are some numerical attributes. For example, the age, the final weight, education none, capital gain, capital loss, and hours per week. We can see that there is a very big difference between the age and the final weight, because the age generally ranges from 0 to 80, 90, 100, and so on. There are big numbers in the final weight. There is a big difference between them. As you have learned in the intuition lectures about the KNN algorithm, a distance calculation is used. So this attribute here will have more importance than this other one, since the values are bigger than the age. So a good strategy when working with machine learning is to normalize all the numerical variables, so they will be in the same scale. For example, all of them will be in the range from 0 to 1, or from -1 to 1, and so on. So it is important to apply this pre-processing. I'm going to open the components, and we can see here the option Normalize Features. There are some ways to normalize the data. For example, normalize to interval 0 to 1. Let's try this one here. When we open the data, see here that now the age and the final weights are in the same scale. The values range from 0 to 1. So one attribute will not be considered more important than the other. We can see that the same happens for the education num, for the capital gain, capital loss, and hours per week. All numeric attributes will be converted in this range. The recommended option is the standardize, which uses the standard deviation using this equation here. We are going to keep this option. A mathematical calculation using the mean and the standard deviation will be made to normalize the data. We can open and visualize the results. See that now there are some negative numbers in the attributes. We can open, test, and score, and see here that the classification accuracy is now 82%. Before applying pre-processing, the classification was only 75. We have a very interesting gain in performance after applying pre-processing. I recommend that when working with machine learning algorithms, before running the algorithms, you apply the pre-processing so the results tend to be better. That's all for this lecture. See you next time.